what we're going to be going over today. Solving rational equations, applications of rational equations, and that assignment, we have a really great way to show you how to make that one pretty easy for you, actually. So near the end, I'm going to be going over a portion of the Semester 1 Honors Project. I'm not going to cover the whole thing. Most of it you'll get pretty well, and we did all post some tutorials on the message board, and this is, like I said, for the honors. So for every part of that honors project, you have a specific tutorial. I just wanted to touch a little bit on some of the binomial expansion, because there's a couple that I didn't really see some examples. There might be a couple little tricky parts there. So near the end, I'm going to go over that. And so those of you that are not in honors, you're welcome to stay for that portion, but it's only going to apply, of course, to the honors. But we'll spend the majority of the time on the solving rational equations and applications of rational equations. A few of you are asking about the collaboration. I can only send this out once, so if you do need the collaboration file, if you didn't get it off your teacher's message board, I'm going to transfer that now. So if you do need to complete your collaboration, make sure that you save this file to your desktop and open it up, and you'll complete that as we go through the lesson. And those of you that have already completed your collaboration, you can just say no, you don't want to save the file. Those of you that are saving, please save it somewhere where you'll be able to go back and find it quickly. And I'm going to be working to two different computers, so if I have a slight pause between slides, it's because I'm having to work between two different computers here through this lesson. So let's go ahead and get started. A couple of things that we need to, I'll wait for that phone to stop ringing, sorry about that. All right. I think that means one of my students was calling and they're not in the live lesson. So, all right. A few things, I put the sign-in information down there for you too. See 1, 2, 3, 4 people maybe that aren't signed in correctly. So you do want to make sure you have your teacher's initial in parentheses before your last name, comma, first name. So just a quick warm-up, you have polling options there. One of the important things that we're going to have to do is find our lowest common denominator. And if you could, you'll see I have some choices there, and you've got your options A, B, C, and D there. Wow, you guys are good at this. Seeing an awful lot of correct answers there, so very cool. Give you about 30 more seconds if you're still working on it there, guys. I've got wow. Apparently you guys are very good at finding the LCD. I'm going to publish the responses here. You'll see here that 44%, and if we look at the percentage of those who actually answered, because we have a few of you that are not participating, but we did have about 70 or so of you that had the correct answer. Okay, so that's excellent. And there were a couple people that selected option B and option D. So I want to look at why option B and option D are not correct. One of the things that we need to keep in mind when we're finding the lowest common denominator, sometimes students, I had someone email me the other day and they said, you know, one of these asked for the lowest common denominator, and one ask for the lowest common multiple. Well, those are the same thing. In other words, if I look at every denominator that I have here, the 4 and the 7 and the x, if we say multiples of 4, we're talking about multiples. So 1 times 4 would be 4, and then 2 times 4 would be 8, and so forth. 3 times 4 is 12. So if it helps you to find the LCD for a few of you that maybe aren't getting it quite right, then just make sure you write out all the multiples of each of those denominators. So 16, 20, 24, 28, and then if we write out multiples of 7, that'd be 7, 14, 21, 28. Here's what I'm looking for, guys. Right here, when I get to the 28, that's the lowest value that's in common to both terms, and I'm just listing out the multiples. So if it helps you to write those multiples out and find the lowest value that's in common with both of them, then do that. Now, the multiples of x are x, and just like you did up here, we did 1 times 4 and 2 times 4 and 3 times 4. So you'd have 2x, 3x, and so forth. Well, nothing here is ever going to match with these numerical values that we have up top. There's no multiple of x that's ever going to be a match to a multiple of a numerical value. Okay, so in this case, you're just going to have to multiply it by x when you get this value here, the 28. Now, this one is an expression, and one of the important things that we need to look at is because now we're moving from adding, subtracting, multiplying, dividing. These were with expressions. Those were operations we were doing with rational expressions, and today we're going to talk about rational equations. So something really interesting here, if I talk about the difference between an equation and an expression, we're really just looking for an equal sign. So here we have the operation of subtraction, but if I just write a little line above that and make it an equal sign, well, then I've turned this into an equation. So the difference between an equation and an expression is literally the equal sign. So if we are talking about a few of the other things you're going to need to remember, just solving regular equations like this, that's an equation. But if I had 2x minus 3 plus 4, that would just be an expression. Of course, we would, combine those like terms over there. But the difference is simply the equal sign that you see. So that's what we're talking about when we say equations. Now, if it's an expression, like this was initially an expression, we would find that common denominator, 28x. And then we would just perform the addition and the subtraction. So we would end up with an expression. We wouldn't end up, with x equals something. But when we have that equal sign, we can say, oh, okay, well, now I'm going to actually solve for x. I'm going to be x equals some numerical value. Or in some cases, x may equal an expression, but it's going to be x equals something, or whatever. If the variable is different than x, it would be a different variable is equal to something. Right? So, like I said, these are a few of the things from previous lessons that we're going to have to know how to do before we can solve rational equations. We have to be able to solve rational equations before we can continue on to application of rational expression, or equations, I should say. So, again, here you see the difference between an expression over here on the left, and then my example on the right is just a regular linear equation, and you see that the difference is the equal sign there. Okay, so over here on the left, we're just adding, and you see the denominator here, 4x. You guys will notice a lot of times your LCD is just going to be multiplying those two denominators. So your LCD here is 4x. And this is just a quick review. If my LCD is 4x, I'm going to have to multiply this term on the left. Since the denominator now is just 4, and I need a common denominator of 4x, I'm going to have to multiply it, you'll see here in the next step, by x over x. Remember, everything that I write in mathematics is always equivalent. So the only way that I can make 3x plus 1 over 4 something in an equivalent form is to multiply it by 1. If I multiply it by any other value, it would actually change the term itself. It would no longer be equivalent. So that's why we multiply by x over x, because x over x is 1. I'm just multiplying it by 1. But in that sense, I'm making the denominator 4x, which I need it to be. Then over here, we had an x in the denominator already, so I just multiply it by 4 over 4. And then you can see the remaining simplification down there. In example 2 there, just something to remind you of, and most of you are really, really good at solving these. You're solving an equation. You do really, really well at that, but I just have a quick example there just to kind of remind you, because we're going to be at a point in all of these where we, 1, have to find a LCD, 2, we have to solve a linear equation. The lesson's going to show you a couple ways to do it. You might remember back from, a lot of you probably had middle school math, we had something called a proportion. A proportion was simply 2 ratios that were set equal to one another. We could solve those by cross-multiplying. Now you can solve rational equations by multiplying as well. Let me show you, somewhat faster way to do that today. So that way it won't, hopefully won't take so long. All right. All right, next slide. You can have a polling option here again. We just talked about this, the difference between expressions and equations, because we're going to be working on equations today. So you have your options there, A, B, C. Actually have an option D as well on your polling, but there's no option D listed. So you have much better chance of having the correct answer if you choose between A, B, and C. But which one of these is an equation? We just talked about the difference between an equation and an expression. I see Mrs. Carmichael participating as well. You are correct, Mrs. Carmichael. I knew you were going to get it right. So here are our results. 93 people not participating, but 66 people did get it right. Guys, if you don't select the polling option, it really makes it difficult for me with the percentages. I have to disregard the 93 participants who did not make a selection and then really work out a new percentage for how many are correct there. But that's not what this lesson's about, so we're not going to do that right this moment. But that is something that we could do. So we do have a very high, what we would do is we have 66 out of 76 with the correct answer. So that's a pretty high percentage, well over 85%. Very good. Remember, as we said in the previous slide, the difference between an equation and an expression is simply the equal sign. Well, the only one here that can be an equation is the one with the equal sign there. So the correct answer is B. Excellent. All right, so let's go ahead and get to what we wanted to talk about today, which is solving rational equations. And solving rational equations is not only fun, but it's also very exciting. All right, and I can sense the excitement in the live lesson room, so that's excellent. All right, so what I'm showing here, and you'll see on the first page of your lesson, they probably won't show it exactly like this, but something similar. I think in the lesson that has like a box over some denominator. Over here you have the same denominator, and then they have some value in the numerator. If you're here on the right, let's say 7, for example. So They said, well, what would you have to put here in the box to make these two equivalent? Well, 7 over 3 equals 7 over 3, right? So I'd have to put a 7. Well, the point they're making there, and I believe that's on the first page of your lesson, is that if these denominators are the same, in other words, here the 3 is obviously equal to 3, and that means the top has to be equal as well. So you have you fill out the box there on just a few, and it'll be pretty simple for you to do that. But the point they're making, again, if denominators are equal, then the numerators must be equal as well. So we start here with this first example. X over 7 equals 9 over 7. Well, if these two are equal, I know 7 equals 7, so that means the x value here must be 9. So that's a process that we're going to use to solve rational equations. So we're going to get our denominators the same, and then we're just going to set the top equal, and then we're not really having to solve an equation with a lot of fractions and things of that nature. We're going to turn these into regular linear equations. Okay. So the second one here, again, you have a common denominator, 7x. All of them have a common denominator. So all I'm going to do is add the values on the top here, combine my like terms, x plus 2 plus 4. And you have a 5 over here. 2 plus 4 is 6, and we're just solving x plus 6 equals 5. So don't let the fractions, I get a lot of questions on fractions. We do a lot of review on fractions. Really, we're kind of getting rid of the fractions here. We're just getting it narrowed down to something more simple for us, which is just a regular linear equation. So we end up turning this, looks kind of complicated here, but really it's just x plus 6 equals 5. Okay? Well, the hard work is getting it down to that one simple linear equation. And another problem we're going to run into is they're going to give us questions that do not have common denominators. So we're going to have to actually get the common denominators before we're able to move on and get our linear equation set up like we want. So what you're going to see here is my Microsoft OneNote. And we'll go ahead and do one. All right. And this should give you an idea. And I'm actually starting out with one that's it's probably a little more difficult. Okay, so we're not going to have common denominators here. So whenever we're going through these, it probably helps a lot if we think of breaking it down step by step. Break everything down step by step by step by step. Okay, so, well, if I were to think of steps, the steps I'm going to complete here, I look here, we had all these denominators, none of them are the same. So that's not a good start, is it? So first thing I would do is find the LCD. Now, if we look at the questions back on that previous slide, well, in those questions, they already had the denominators were the same. So, of course, when we run into a scenario where the denominators are the same, well, I guess we get to kind of skip step number 1. We're not going to need to find a common denominator at all. Okay? But in this case, we definitely have to find a common denominator. And this is not so easy to find the common denominator. So let me open the chat and see if anybody can tell me. I'm just curious. Anybody tell me what the common denominator is here? A lot of you are very close. John, very nice. Caitlin, good. Okay. A lot of you are on the right track. So this one is it's a little more difficult. Jordan, that is correct. A little more difficult to find the common denominator. Remember, the common denominator is also the least common multiple, or lowest common multiple, some call it. So I think of multiples of these values. I have to think, okay, well, what are multiples of 2x? Well, 1 times 2x would be 2x, so that's a multiple of 2x. Remember, it's 1 times the number, 2 times the number, 3 times the number, 4 times the number. Keep moving up and up like that. So we would have 2x, and then if we did 2 times 2x, we get 4x. 3 times 2x, we get 6x. So these are going to be my multiples of 2x. Like I said, if it helps you to write out the multiples, that's not a problem. Multiples of 5x. Well, 5x, 10x, 15x. I already see the 10x in common here. I know 10x is going to be part of my common denominator here. Now, what we have to worry about now is this. I don't know who came up with this question, but I'm going to have to talk with them, trying to come up with these real hard math questions. This x plus 2 over here, well, let's think about what the multiples of x plus 2 are. You have 1 times x plus 2. I know that that's just x plus 2. And you have 2 times x plus 2. I'm not going to distribute it because it would be irrelevant. I'm never going to end up with a 10x, right? So in these type of problems, we're really looking at finding your common multiple between these two, the 2x and the 5x. And whenever you have a binomial down there, you're always going to have to multiply it by that binomial. So my LCD here for step 1 is going to be 10x, and a lot of you had this correct, times x plus 2. Remember, you won't necessarily get your lowest common denominator if you just multiply all the denominators together, but if you complete all of your steps, all the processes without any calculation errors, you'll still actually end up with the right answer. If it seems really confusing for you, or it's a bit too difficult, just multiply all those denominators together. You'll get an LCD. Like I say, it might not necessarily be the lowest common denominator, but we can get a common denominator, and a common denominator does allow us to combine these terms. All right, so that's step 1, find the LCD. So step 2, after I find the LCD, I'm going to have to multiply all of my terms by whatever they don't have. In other words, this first term, if I look at 1 over 2x, well, my common denominator, I said, well, my common denominator is 10x times x plus 2. So now we have to think, all right, well, what do I have to multiply this 2x by to get my common denominator? We're going to multiply the top and the bottom by that value, but in this particular case, I'm really only looking at the 2x. How do I get this 2x to equal 10x times x plus 2? Well, I'm just going to have to multiply it. If I multiply 2x by 5, right, that would give me the 10x. And then I'm going to multiply it by this binomial here as well. So let's write down that first part, 1 over 2x. And I'm going to have to multiply it top and bottom here, by 5 and by x plus 2. Remember, we can only multiply it by 1. So whatever I multiply the bottom by, I have to multiply the top by. Right. Remember, guys, this also in not last week's lesson, but the week before. We're just adding a rational expression on the left-hand side. If we just completely ignore what's happening over here, then this is something we've already learned to do, is to add rational expressions. All right. So next, we have 1 over x plus 2. But how do I make that 10x times x plus 2? Well, that one's not as bad because I just multiply top and bottom by 10x. Right. And that equals 5 over 5x. So to get a 5x to equal 10x times quantity x plus 2, I'm just going to multiply top and bottom there. By the way, I've got a few students that are on use netbooks, and maybe you have a smaller screen on your laptop. Sometimes when I get too far over here to the right, you might have to use your scroll bar down there at the bottom. But all I'm doing is multiplying 5 over 5x by 2 times the quantity x plus 2 over 2 times the quantity x plus 2. Now we just have a lot of distribution and things of that nature. But 1 times anything, you know, I don't really have to worry about the 1, so I'll just distribute my 5 here to everything. That's going to give me 5x plus 10. Remember, on the bottom here, we're going to get 10x times x plus 2. I would still go ahead and perform the calculations down here just to make sure that you are indeed multiplying it by the right value. If we're multiplying it by the right value, then we are going to end up with the common denominator, 10x times x plus 2 over there. And this one's not so bad, just 1 times 10x. And I'm not going to continue to rewrite that entire denominator because we're not going to need it in a second. That's kind of our super top secret shortcut. Anyway, over here, 5 times 2 is 10, and then 10 times x plus 2 will give me 10x plus 20. And again, you know, like I said, I'm not going to rewrite the denominator over and over, but all the denominators are 10x times quantity x plus 2. Hello, hello. Sorry about that. My internet's acting a little funny there. Sorry about that. All right, so we got it down to a linear. You know, like I said, if these denominators are the same, okay, if the denominators are the same, then the top has to be the same as well. So I highlighted in yellow there because we don't need to pay attention to the denominator. We don't even need a fraction. Keep this in mind. And this is kind of interesting. Remember, when we're solving a proportion, which any two ratios that equal to one another create a proportion. You can actually cross-multiply this to solve it. And as you can see here, if you do cross-multiply to solve it, you're going to end up with a quadratic. Well, that's not necessarily a bad thing. We know how to solve quadratics. We had a whole, you know, nearly a whole unit on how to solve quadratics, right? So we know how to solve quadratics. But we talked about, I think it was Mrs. Gray last week, talked about discontinuities, and the discontinuities were based on these denominator restrictions. Now, if you actually cross-multiply and solve out the quadratic, you'll probably end up with the restricted value in some cases. Well, the restricted value is not a solution anyway, so unless they want us to tell them what the restricted values are, we don't really need to worry with that. But if you don't have to deal with the quadratic, I would think this is a lot easier to solve here than dealing with something, especially what I'm looking at now. I'm going to have, if I'm thinking of cross-multiply, I'm going to have 100x squared on one side and 150x squared. So I'm looking at some very large coefficients to my x squared term. So that's something I personally would like to avoid. So, but anyway, and you could go ahead and solve this out pretty quick. Like I said, whenever I have variables on both sides, I just like to get the variable on one side to start. Remember, there are many different steps that technically would not be incorrect here to start off. All right. And then subtract your 20 from each side. So that's the process. Well, I know you don't need to see the, oh, somebody's telling me, Willie's helping me out here. Oh, it's a 15x. Thanks, Willie. Side x would be negative 5x. Well, thanks for keeping an eye on me there. All right, now, then from here, of course, we just divide each side by negative 5. You end up with negative 10 equals negative 5x, right? So you get x is 2. And I already had this. This is actually for a little bit later in the lesson. But I did want you guys to see here that we can plug that solution in and check and make sure that we have the correct answer. So let me just get rid of this if I can here. We'll just put that way down here for later when we do our super fun binomial expansion. All right, so we can plug that in, and then we can check our answer. So we'd have to go all the way back to our original problem up here, which is the 1 over 2x plus 1 over x plus 2 equals 5 over 5x. We have to plug a 2 in. And if you are checking your answers, you are going to need to be pretty good with working with fractions, because a lot of times, obviously, in this case, I can tell when I plug a 2 in, I'm going to end up with 1/4 there on the left, and 1/4, so 1/4 plus 1/4. So we will need to be able to add those fraction values. All right. So we need to think of, well, what those steps result in there. And like I said, this is one of the more complex that you'll do. Probably one of the more complex. We can, I'll do one that's even a little simpler here after this. But we think of our steps. We had to find the LCD. And then what would you call that? You can kind of just give me some ideas. We can make up the name of it, make our own cool mathematical thing now. But what would you call that? After I found the LCD, I had to make sure all of them had the same LCD. What do you think that would be called when I'm trying to have the same LCD for all of these terms? We have to think of a way to make that a step here, a step to our process. And what I'm referring to is this, and you can kind of give me some ideas there in the chat box. Students ask me frequently, if maybe they're having a little trouble with a certain concept, and they have these notes, and they're looking at their notes, and they say, well, I look back at my notes, but I just don't get it, So we have to come up with ways to write these steps in a language and a verbiage that we're going to understand when we look back at our notes. I have to think of a way, okay, well, what do I do after that? I could say, well, I get all the denominators to be the same. Maybe I'm multiplying by the missing parts. All right. So however you want to name that step is up to you, but you need to have it a way in your notes that you're going to be able to look back at it and understand exactly what it is that you're doing during that step. Step 3, well, that's pretty easy. Really, all I did for step 3 is I added my fractions, right? So you could say, hey, I add and subtract, or perform your operations, or I say combine like terms. Okay. And then once we've done that, we have all the denominators the same. We have one ratio equal to another ratio. All I did was make a linear equation out of the top. That's this part down here circled in purple. All I did was focus just on the top. Okay. So let's make this one a little easier. All right. And you guys can work this one out. Let's say I have 3 over 2x equals 7 over 4. It looks like you're going to get a fraction answer, by the way. So I'll give you about 2 minutes. See if you can give that one a try. Remember, when it's something with, there's only one x value here. This one wouldn't be too difficult to solve by cross multiplying. We'll give you a couple minutes to work that one out and get me the answer for x. It looks like it's going to be a fraction, by the way. That's a hint. And then I'll come back and I'll show you the cross multiplication way, like the way that we would do it if we were solving a proportion. And then I'll also do it the way that I showed you on the previous problem. So I guess we don't need 2 minutes. Some of you are solving that. I'm just solving that one faster than I can solve it. I haven't worked it out yet. So when I'm seeing that many of the same answer, though, I'm assuming that you're correct. All right, so let's work it out both ways, and then I'll also go through that process of checking your answer, right? Mrs. Carmichael, I agree. So if that many people say that that's the answer, then it must be, right? All right, so I'm going to do it cross multiplication first. Like I said, this is the way we solve proportions. So 3 times 4 equals 2x times 7. So 12 equals 14x. Divide each side by 14. And then that 12/14 reduces to 6/7. Right? So, and that's the answer I saw in the chat box quite a few times. So it looks like everybody's on the right path there. Now, that's the way that, like I said, if we're doing cross multiplication, let's solve it the other way, the way that I showed you up top there. So if we start out with 3 over 2x, I'll leave myself a little space there since I'm going to have to multiply both of these. On my LCD here, if I'm doing it that way, it looks like it'd be 4x, right? So over here, I multiply top and bottom by x. And then on the left, I multiply top and bottom by 2. Hopefully, Willie's paying attention in case I mess up again. All right, so let's do top. 3 times 2 is 6 equals 7 times x, 7x. And then to solve, we just divide each side by 7. So we get x equals 6/7. Now, we come up with the same result either way. Right? But like I said, in this case, cross multiplication, yeah, pretty good way to solve it, just using it a proportion. But like I said, in the case above, well, if we did cross multiplication after we simplified, you're going to end up with quite a handful of a quadratic there, okay? Quite a large quadratic that we'd be dealing with some huge coefficients. So it'd be a lot of calculations to put put in a quadratic formula or anything like that. So now let's go ahead and check our answer. If we look here, I got an answer of 6/7, and I'm looking up here at my original problem. 3 over 2x, well, I'm saying x is 6/7 equals 7/4. So remember, was it last week or the week before, we just went over this complex fraction. Now I've got a fraction over a fraction. So when we go to solve this, once again, you'll see that you do have to have some good fluency with operations on fractions. So if I look here, I'm just going to multiply 2 times 6/7. Well, it's going to give me 3 over 12/7 equals 7 over 4. Well, remember, when we've got a complex fraction, this is 3 divided by 12/7, which is the same thing as 3 times 7/12, which equals 21/12, right? 21 and 12 are both divisible by 3, so we could reduce this. 21 divided by 3 is 7. 12 divided by 3 is 4, and then look what you end up with here. So we can always check our answer there, make sure that we did all of our calculations correct. Like I said, that's a more simple problem. It's great to look at, okay, we can use cross multiplication, or we can find that common denominator and just set the numerators equal to one another. And remember, we always have to simplify. And like I said, if we keep looking back at that first problem here, which is kind of a mess now, but all the way here up here at the top, I have to simplify that before I set the top equal. In other words, that addition sign there, I've got to make that addition before I set the numerators equal. So you always have to combine it and simplify it. So either way, you're putting a lot of different things, not just in this unit, but from previous units together there as we go through. So we have to remember how to add, subtract, multiply, divide, rational expressions, solve linear equations. We have to think, we have to know all these things about multiples and factors and things of that nature as well. All right, so we're going to look now. And by the way, guys, you can, of course, have a lot of your own practice problems that you'll do in the lesson and everything. So time's kind of gone by pretty quickly here. But fortunately, the way that I'm going to show you how to do the next lesson, and it should make it pretty easy for you. All right. Here's the example. So when you guys do this lesson, this is pretty much what you're going to do. Of course, I don't want you to use my example. I don't want you to use 3 and 2 or 2 and 3. So, use some different values. But if we look here, and this is type of question, this is exactly like your assignment. I mean, this is going to be pretty easy for you guys. All you're going to do, you're going to come up with a scenario. It could be I've had students use mowing the lawn or painting the house, or just a lot of different things they come up with. Sometimes they come up with things that are very amusing, as a matter of fact. Now, one person can do whatever job. In this example, Mr. Shreeve can clean the house in 3 hours. But you're just going to have you and another person can do any task, doesn't matter what the task is, and you can do it in a certain number of hours. I would keep it to hours, by the way. If you get it into minutes, it's going to be a lot more difficult because you're going to be dealing with a lot larger numbers in your denominators. So I keep it in hours. And then in this case, the brother can clean the house in 2 hours. So someone else, maybe a sibling or a parent or a friend, they can complete the task in a certain number of hours. And look at where these all correlate. Now, the 3 hours, you'll see, I just put 1 over 3. So I can do one task in 3 hours and I make that my first denominator. The top is 1. We try to make this one pretty easy for you. The next one, you could complete the task in 2 hours. So that's 1 over 2. And this part on the far right is going to be the same for everyone. So whatever your 2 fractions are on the left, they're all going to equal 1 over x. This is an example, too, that kind of goes with what we were doing earlier when we talked about finding that LCD. In this particular case, the LCD is just everything multiplied together. 3 times 2 times x. 3 times 2 is 6. 6 times x is 6x. So find your LCD. And remember, in this next portion here, you can see the steps I already worked through them. But it doesn't show you there, well, I had a 3 in the denominator of my far left fraction, but I needed the denominator to be 6x. Well, what would I multiply 3 by to make it 6x? Well, it would be 2x. So you multiply top and bottom here by 2x. Like I see, in this case, you're going to get 2x over 6x. Again, once we get these denominators the same, we're just doing what we've done in the previous lessons. We're just adding or subtracting, in some cases, rational expressions. But all of yours are going to be addition for this particular assignment. But really, all you're doing is replacing the denominator with how many ever hours it took you to do a certain task. And then the next denominator, how many hours it took someone else to do that same task. And then how much time it would take you to do it together is going to equal 1 over x. You can actually copy this down and just, you'd be able to kind of swap some numbers around. All right. Once we had the denominators the same, just as we did previously, we're just going to set the top, because if the bottom's equal, the top has to be equal. You notice I just, totally don't even deal with the denominator anymore. So 2x plus 3x equals 6, 5x equals 6, and then we're just solving the linear from that point. That's all you're going to do for your applications of rational equations assignment. So that one is not very difficult at all for you. All right. Of course, if you do need help, make sure you reach out to us and let us know. Now, I will accept this answer. And I didn't discuss it with Mrs. Gray and Mrs. Carmichael, but I always accept the fraction as the answer. Now, if your teacher does want you to convert that, because we were talking about hours, then we would have to actually do 6/5 times 60. So I don't know, Mrs. Gray and Mrs. Carmichael, if you make them do that, but I leave it as a fraction. Yeah, because you're going to end up here with 1 1/5 hours. Well, 1/5 of an hour, remember, it's not 1/5 times 1, it's 1/5 times 60 minutes. So make sure your conversion from hours to minutes, if you're going to put it that way, like I said, I'm completely fine with you just leaving it in that fraction form for your answer. Okay? And that actually gets those of you that are not honors, it gets you done with the lesson about 10 minutes early. What I'm going to continue with at this point only applies to the honor students that are here. So those of you that are not in honors, you are free to go. Thank you for coming. And those of you that are honors, I'm only going to go over one portion of what we were, what you're going to have on your honors project. For those of you that haven't looked ahead, or maybe you're a couple assignments away from getting to this point, you have a semester 1 honors project. And it's a really cool project. It shows you some pretty neat stuff. Some of the stuff, to me, what it looks like is it's just some things that are going to prepare you, because a lot of the honor students are more than likely headed into pre-calculus next school year. So these are some things that you'll need. Now, a lot of the stuff is just going to be, just regular operations on complex numbers. A lot of it's going to look probably pretty easy for a lot of you, I guess. In other words, it's stuff that's been introduced in the lessons. It's all operations and values and expressions that you've dealt with in the lessons, functions that you've dealt with in the lessons. There's not anything new or tricky or anything like that. Now, one thing that you have not been introduced to in the lesson was just the binomial expansion. And we use something called Pascal's triangle for that. By the way, I'd like to thank Mrs. Gray for this awesome picture of the Pascal's triangle. I always write it down on my paper, and you know, this is really nice to have the triangle right there for you. I want you to notice a couple things. If you look at the triangle itself, you'll see a pattern. I want to make a special note, though, that this top row is not row 1, it is row 0. That's going to be important in a couple minutes. So you'll notice everything on the outside of the triangle is a 1, always a 1. And then if you'll look right here, let me change to my highlighter real quick. You'll see that 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3 as well. See how these values on the inside, they're all determined by adding the 2, the one up top left and top right. So you could continue this triangle, you know, to 150 rows if you want. Continue it for a long time. We're not giving you any questions, I think, past a 6-degree expansion, so I don't think you'll need anything past the 6th degree. When you do your college algebra, you maybe will go up to 12, 13, 14, 15, something like that. So, and you'll need a really good calculator for those. But this triangle is pretty critical. And like I said, if you just think of the pattern to build it, then you can always make that triangle on your note page or while you're taking a test or working on this assignment even, for example. So that triangle makes absolutely no sense unless we put it in a proper context. So let's do that. I'm going to share my OneNote here with you. I thought I was going to have time to do a couple of these, but well, maybe we can. We've got about 8 minutes. All right, so that's that problem down here that I had to kind of move down. This is what we mean by binomial expansion. So it's a plus b quantity to the power of 4. You know, if I just had a plus b squared, I'd probably pretty quickly do that one in my head because it's a perfect square trinomial. And even cubed is not too bad because you can just write it out and manually distribute everything. And yeah, it might be tedious and take a while, but you could do that as well. But here's what we use the triangle for. And you know, since I don't have it over here, I got to kind of make myself another little triangle over here. But remember, it's pretty easy to make the triangle because it's a very specific pattern. I'm only going to go to row 4 because both of my examples here are 4th degree. All right, now it's going to get somewhat complicated, so that's why I show you with just an example with A and B. And then the last example that I'm going to do, I wanted to show you because I don't believe I saw in the lesson anything with a subtraction with both values having a coefficient. And that gets a little more complicated, so I wanted you to have an example of that. I think I've got one. It's not a subtraction. I think it's an addition one on my blog where I do for a 5th or 6th degree, something like that. All right, so all I do here first, I look at the exponent 4, and I say, okay, well, if my exponent's 4, that means I'm going to go to row 4 in my triangle. So I go over here and I'll look at this row 4. I should put a little hyphen between these. And this is just me labeling my rows. I always have to do that or I'll forget, and I'll think that row 3 is actually row 4, so I always label them, right? 0, 1, 2, 3, 4. Just remember technically your first row is row 0. All right, so what we're going to use the triangle for is this. Row 4, and I'll go ahead and write out my row 4 over here. We're going to use these as coefficients. So help me do an expansion. It's still a bit of work to do. It's a lot quicker, though, than foiling the first 2 binomials and then taking that resulting trinomial times another binomial, and then you'll end up, of course, with a 4th term that you're multiplying by the binomial. All right. So check this out. It's pretty neat. This 1 right here, I'm going to put out here, it's a coefficient. And then I'm going to have both of these values that are in the parentheses. So I've got an A and I've got a B. Now, every one of the terms that I write is going to have a degree of 4. And this is one of the tricky parts. This is going to take you some practice. Don't get discouraged when you see the complexity of this. But my first term here, A, is going to have a degree of 4, and this is going to have a degree of 0. Because 4 plus 0 equals 4. Every term is going to have a degree of 4. And you're going to start to clear up a little bit for you as I move through it here. Plus, and now I've got to use my next coefficient 4. And then I've got my A and my B. And what you're going to see is my exponent on the A is going to decrease by 1. The exponent on the B is going to increase by 1. And that's going to continue to happen, but they're always going to have a degree of 4. So next I'm going to take my 6 coefficient. So now instead of A cubed, it's A squared, B squared. Like I said, the A exponent is just decreasing by 1, while the B exponent is increasing by 1. All right. So next I'm going to use my 4 here. Oh, I forgot my plus sign. And now I'm going to have A to the 1, B to the 3, and then our last coefficient of 1 over here. And this is going to be A to the 0, B to the 4. Okay. Now, remember your rules of exponents. Anything to the power of 0 is just 1. So 1 times A4 times 1, just A to the 4th, plus 4A cubed B, plus 6A squared B squared, plus 4AB cubed, plus B to the 4th. All right. And like I said, don't forget, there's another complete tutorial on this. I'm not sure. I think maybe Mr. Welch did all 4 of those from the honors, but you have a tutorial for every part of this honors project. Like I said, this one I just wanted to make sure that you saw a specific example that I didn't really see anything, and I thought I might see some mistakes on this if I weren't able to show you exactly how to deal with this subtraction in the middle and coefficients on each of the terms. All right. Now I show you the A and B example because that's exactly what you're going to do, but we're going to get into a whole lot of parentheses and a whole lot of large values. Okay. And by the way, guys, it's 2:58. So even if you are honors, if you need to go, you're certainly free to go. The recording will be up in a bit. But this is going to take a second. We'll probably run about 5 or 7 minutes over. If you do want to stay and see it worked out, that's completely fine. But if you do need to go, I certainly understand. Again, I write out my triangle. That's a 1. All right, it's 4th degree. I see the 4. That means I'm using 1, 4, 6, 4, 1. All right. And like I said, You're going to have to do some practice on these. Start with the easier ones. I'm just wanting you to see an example. Just little things that I see that are common mistakes when students are working through these. All right, so the first one, I'm going to have my 1 coefficient. That 1 comes from the triangle, right? That's my coefficient. And then I'm going to take my first term of the binomial, and I'm going to make sure that, remember, it's always 4th degree. It's going to start at 4 and end in 0. The second term is going to start at 0 and end at 4. Just like that. Okay. Actually, I've already made a mistake myself. This is a negative 2y. That's another thing that I do personally. I look at that second term as a negative 2y. In other words, I think of it as 3x plus a negative 2y. That helps me because we're going to end up with some issues with the signs here in a moment, but that allows me to add each term. I don't have to really concern myself with the sign. Just going to always add each term, and I'm going to look at that second term. If it's subtraction, okay, then you're going to make sure that I would do it this way. You know, like I said, this is the way I do it. Mrs. Gray, Mrs. Carmichael, Khan Academy, Mr. Welch, some of the tutorials, they might have some other cool things to show you that work really well. And, you know, some might work great for you, and the way that I explain it, maybe not so great. So you want to see this presented in as many possible ways as you can. All right? I'm going to kind of have to remove a little bit of my triangle here. So next coefficient there from the triangle is the 4. The 3x is now to the power of 3. The negative 2y now to the power of 1. Okay. Plus, then I pull down the 6. The 6 is from the triangle. So all I'm doing, remember, is the first term in the binomial and the second term in the binomial. Just remember your pattern of exponents. It was cubed here, it's squared here. The degree is always going to equal 4. It's going to equal 4 when we're dealing with the 4th degree expansion, guys. I don't want that to be misinterpreted as every expansion you do will have a degree of 4 in every term. So if it were a 5th degree expansion, every term would have a degree of 5, of course. All right, now you'll also notice one of the reasons why these are difficult for some students is it's hard to keep all your work in one line. Sometimes I'll have students, back when we were doing it in the classroom, we'd turn our paper sideways because you have to write out such a lengthy expression here. But all right, so let's go. Next value on my triangle there is 4, so plus 4 times, now the 3x is to the power of 1. The negative 2y is to the power of 3, plus 1 coefficient from the triangle. The 3x is to the power of 0. The negative 2y is to the power of 4. All right, like I said, so one of the reasons I wanted you to see this example. When we don't have an addition sign in the binomial that we're expanding, it's going to get pretty complicated with the signs. But the good news is we're still just following order of operations here. All right, so we're going here from this 1 times 3x to the 4th times negative 2y to the 0. And when you expand that, make sure you follow order of operations. Remember, this 3x to the 4th is 3x times 3x times 3x times 3x. All right, so 3 to the power of 4, or you could think of just properties of exponents here. If it's a term in parentheses, then each value in that term has to go to the power of 4. So 3x to the 4th is going to give me 81x to the 4th. Negative 2y to the power of 0 is just 1. Doesn't matter if it's negative 2y or positive 2y, anything to the power of 0 is 1. So we don't have to worry about the sign in that particular case. Now this next term, I'm going to go ahead and just go left to right on these, especially these ones in the middle. I don't try to do too many steps at once. So 4 times 3x cubed. Well, order of operations, sorry about the phone ringing. Anyway, order of operations, if I'm doing 4 times 3x cubed times negative 2y to the power of 1, I go ahead and deal with that exponent, the 3 exponent first. Okay? So 4 times, you know, I'm going to put the 4 out here, and I'm going to do my 3x cubed. So 3x cubed is going to be, Willie, are you still here? In case I make any calculation errors. I'm trying to hurry so you guys can get out of here, but so I'm calculating this in my head. So now I'm doing this one right here. So this isn't too bad. 3x squared, that's just 9x squared. Negative 2y squared, that's just going to be 4y squared. Notice there my sign turned positive. Okay. Then next, 4 times 3x is 12x. Really, I should, you know, technically I do this other part first. Negative 8y. Negative 2y cubed is negative 8y. Remember, with the odd exponents, if it's a negative base, we're going to end up with, oh, who's that, Devin? Which one? Oh, were you talking about in this first term here, 2y to the 0. Anything to the power of 0 is 1, so yeah, so we don't need to worry about that. It's just times 1. You know, 1 times 3x to the 4th times 1. So yeah, anything to the power of 0 is going to be 1. So, all right, 12x. Oh, is this correct? Where were we at? Oh, right here. Okay, good. So 12x, and that came out to negative 8y cubed. And then, yeah, you'll have a negative 2y right here. But it's going to be multiplied. When we multiply it out, there's not going to be a negative 2y anywhere. All right, so now we're down to our very last one right here, which is 1 times 3x to the 0. That means 1 times 1. So really I'm only dealing with the negative 2y to the 4th, and then 2 to the 4th is 16, right? 16y to the 4th. Now, like I said, even though I am doing more of this than I would like to kind of quickly in my head, I'm still kind of writing out, see, this still has a lot more simplification to go. Well, technically, our first term and our last term are already done. And so 81x to the 4th. And then here, if you want to go left to right, if you want to do your 4 times the 27 first, you know, I would probably say that that would be a good idea. You could just have a lot of room for errors on these. So I just did 4 times 27. 4 times 20 is 80. 4 times 7 is 28. So 108 x cubed times negative 2y. You know, I didn't do that calculation there in one step. I'm still going to multiply that next step. 6 times 9x squared. 6 times 9 is 54, right? 54x squared times 4y squared. So I'm still going to have to multiply this 4 and 54. It's okay. I'm just taking my time and trying to make sure I don't make calculation errors. And then we've got the 12x times negative 8y cubed. Now that's a positive times a negative, so here we end up with a subtraction. And then the last term we already had simplified. All right. So now we're getting to a point where hopefully we'll be able to fit all of this on one line. Like I said, if you're doing them on paper, I just turn the paper sideways, or as they call it, portrait view, I believe, right? So now we got 81x to the 4th. And then this is a positive times a negative. So it's going to be 2 times 108, 2, 16, x cubed y. And then 54 times 4 is 216 too, right? That's a coincidence, so don't expect these two numerical values to be the same all the time, guys. That's a complete coincidence. 96xy cubed plus 16y to the 4th. And that's that. So that's the complete expansion. Like I said, I've got